Nice to meet you. I'm Kadir Choktai and you're watching my YouTube channel, School of Advanced Chemistry. I'm going to solve question number 1, part E, October-November 2023, 2-3 variant. POCl3 gas forms when PCl3 gas reacts with oxygen, O2 gas. Here is the equation. 2 mole of PCl3 is going to react with 1 mole of O2 to give 2 mole of POCl3. Table is given. In this table, enthalpy of formation of PCl3 is given. Enthalpy of formation of POCl3 is also given, and this time when O2 is going to break into 2 mole of atoms, then answer is given that is said to be enthalpy of atomization of oxygen. Enthalpy of 2 mole of atomization of oxygen. Part 1, define enthalpy change of formation. Number one enthalpy change. Enthalpy change. Number 2, when 1 mole of compound is formed. Number 3, from its elements. Number 4, under standard conditions. Now come toward the next one portion, this one. Calculate the bond energy of P double bond O in POCl3 using the data in the table 1.3. Show you working. So basically, whenever they are asking to find the bond energy or the bond energy is given, then formula number 1 is used. Number 1, delta H is equal to bond energy of the reactant minus bond energy of the product is used. So in this case, if they are asking to find the bond energy of PO that is lying on the product side, this one, POCl3, this one, the first step is to make POCl3's displayed formula, and PCl3's displayed formula is this one, PCl3. It's a 2 mole, 1 mole O double bond O, and goes to this one. So whenever they are asking to find the bond energy, or they are asking that the bond energy is given and find the delta H, then we will make a displayed formula of all species on the both side, right hand side and the left hand side, and then we will count the bonds. Number 1, in this case, first of all, as I told you, first I'm trying to use this formula. So first of all, I'm going to check the net bonds on both sides. What does it mean? It means that PCl bond 1, 2, 3, 3 2s are 6. On left hand side, there are 6 PCl bond, and same is the case, 2 into POCl3, and again here are 3 into 2, 6 PCl bond on the right hand side. Basically, I'm going to cut these bonds. All PCl bond will be minus, or they are equal, will be cancel out, because they all are equal and they all are present on both sides. So what is the overall change over here? Over here, the overall change is O double bond O is going into 2 mole of P double bond O. So that is the net change. Now what to do? I'm having the atomization of oxygen. I'm having the atomization of oxygen, and the bond energy of O double bond. I can calculate it from here, from this data. Yes, if I'm going to break this O double bond, obviously 2 mole of oxygen will be formed. At that time, how much energy is required? plus 496. So this value can also be known as 2 mole of atomization, and its value is also the bond energy of oxygen, because there is no change in the physical state before and after the chemical reaction. So bond energy can be equal to enthalpy of atomization. But I'm no more needed this enthalpy of atomization. I'm going to use this bond energy, that is 496. So bond energy of the reactant is equal to 496, and reactant minus product into 2. Let's suppose the bond energy of PO is equal to X. This time we must be having the answer of delta H, but we are not having the answer of delta H. So at the moment we are unable to find the answer of P double bond O. Now, how to find the answer of delta H? I'm going to apply another formula. As the given data of enthalpy of formation is over here, so I'm going to use the enthalpy of formation data with this equation. What is the equation? 2 mole of PCl3 plus oxygen goes to 2 mole of POCl3. Enthalpy of formation mean there are two compounds and they both are being formed. So I am going to write element first. Phosphorus plus Cl2 plus oxygen. For the sake of balancing, especially balancing this left hand side, I need 2 phosphorus, I need 6 Cl atom overall, 3 2s are 6, and 1 oxygen. Okay, closed. This is the one packet of element that is making POCl3 and O2 as well. And here I'm going to draw this arrow of enthalpy of formation that is equal to 0, because whenever you are going to move from element to element, there is no enthalpy change. So there is no need to write or there is no need to draw this arrow. The next and third arrow, this box can be used to make 2 mole of POCl3 as well. 2 phosphorus, 3 2s are 6 Cl, and 2 1s are 2 oxygen. Equation is balanced. So 2 into enthalpy of formation of POCl3, 2 into enthalpy of formation of PCl3. After putting these value, I can find the answer of major overall enthalpy change of this reaction, of major reaction. So enthalpy changes: PCl3 minus 289 minus 289, and its answer is minus 592 minus 592, and here this is the missing enthalpy. So now I can apply the Hess's cycle, or simply there is another way out, that delta H is equal to enthalpy of the product minus enthalpy of the reactant. Or you can use Hess's cycle or Hess's rule, or you can use this formula as well. So what is the enthalpy of the product in this case? Enthalpy of the product is this one. So 2 into minus 592 minus enthalpy of the reactant is this one, 2 into minus 289. So what is the overall answer of delta H for this reaction? What is the answer of this one?